Hello everyone. This is lecture series 8 under Computer Networks Lab dealing with the 8th experiment. Come, let's go into the video. Please do like, share, subscribe and comment. So in part B, in the last series of video, we have seen the first program, HLDC frame. In that frame, we have performed how bit stuffing and character stuffing is done. Now in this video, we'll be seeing about a program for distance vector algorithm to find suitable path for transmission. So this is nothing but you will have different nodes at different area. So one A, B, C and D nodes. So these nodes, when they are transmitting the data or frames from one end to the other end, it should follow a path suitable for it. Maybe it might be the shortest path, or it might take the longest path, or it might see whether where in which path the traffic is lesser, so it might choose that particular path. So this is how we design a distance vector algorithm. We are going to measure the distance between each nodes. So for that, include stdio.h. It has to accept the input and output, and you have struct node. It is nothing but it is the structure that you are creating called node. And here you have unsigned thing. One is distance. So distance of 20 is a character that you're assigning, maybe from one node to the other node, and you're giving an algorithm RT. Then here you have main function int dmat, that is distance matrix. Dmat is nothing but the distance matrix. So you're defining it as 2020, and you're initializing nijk, count, all these to be provided in the loop, and count will be 0 because it has not measured any of the distance, so it is 0. Now printf, you are giving enter the number of nodes. So here if you have 4 nodes, A, B, C, D, 4 will be the nodes, and that nodes will be red, and you're going to enter the cost matrix. So here what happens is cost matrix 999 for no link. So why you are giving no link is, now see here how you will be entering the matrix is first AB, then AC, AD, A to A. Okay, like that you will be entering. So now A to A will be 0. There is no distance, so you will be you will not be giving it as 0, because if you give it as 0, the algorithm will take it as a null packet. So you are going to give it as 999. So A to B will be 2 and A to C will be there is no link, so 999. Then A to D will be 4. Like that you will be giving for each of the nodes. Then next matrix will be formed with B as a node, B to A, B to C, B to D, B to B. Like that you will be keep on putting C and D. So you'll be forming the matrix. If there is no link and if it is 0, you have to mention it. If it is no link, you have to mention it as 999. So now for I is equal to 0, I lesser than n, I plus plus. So now you are starting with I is equal to 0. This will be counted for n number of loops. So it should be lesser than n. N you will be defining like how many matrix you are forming based on the nodes, what is the length of the matrix that you have formed. Okay, so then J is also formed as one loop. Now what happens is scanf percentage %d and dmat I comma j. Now I comma j is nothing but, so first what is the distance that we measured? A to B. So A will be I, B will be j. So that is called as matrix, data matrix I, distance matrix or data matrix I and j. So if I of I is equal to 0, then what you are doing is you are giving a routing algorithm to measure the distance between that particular node to the next node. The same way you're doing it from that point to the other node. Okay, now your count is 0. Again you are putting for loop for I, j, k. Now 3 for loops. If the distance matrix, that is dot I dot distance j is greater than, so the routing algorithm, and for a particular node distance, if it is greater than a defined matrix, plus where it is going to calculate the distance of that defined matrix also, if it is greater, then what happens is you are going to measure again, that is you are going to you are going to equal that to the k value. So k value is that is already running inside the loop. You are going to take all the values of the nodes a to b, a to c, a to d, a to a. So and you are going to measure which is the shortest path or what is the distance between each of the path. Then you're incrementing that node. So first for a node it will be repeated, again it goes for the b node, c node, d node. Likewise it is counting, incrementing and doing for all the nodes. Then printf state value for router. Now for router you are going to set a value, that is via node 1 to node 2 what is the distance, or via node 2 to node 3 what is the distance. You're going to set a distance. So for that, node percentage d via percentage d distance. So first you will take one node, and with that node you are going to measure the distance, which is going to be j plus 1, that is distance between that node, the next node, the other next node, like that it keeps on increasing. Okay, so now whatever value you are getting, that you will be printing here. So this is what the concept of distance routing. So now after typing all these, you will be saving, and in the terminal you will be giving dot bar a dot out. So in the previous thing we were saving it as ns.tcl because we created nam and trace file. Here you are going to just get the output. So number of nodes is 4 nodes you are considering, and you are creating the matrix like you are creating a to b, a to a is 0, a to b is 2, a to c there is no link, then a to d 1, distance is 1. So like that you're going to form a matrix, and your state value for router 1 is, now you're going to state the value for router 1. So node 1 via 1 will be 0. Okay, node 1 via 1 will be 0. Node 2 via 2 will be 2. Node 3 via 2 will be 7. Here you are giving the distance. Here there is no value. You are particularly giving one distance. Okay, node 4 via 4 is 1. So like this for router 2, next router. So node 2 via 1 is 2. Node 2 via 2 is 0. Okay, so you will be, if you want, you can give value. Node 3 via 3 is then 5. Like that you will be setting the router value for each of the thing and finding the distance. So this is the output that you will be seeing in the screen. Hope you have understood the concept how a distance vector algorithm performs. Stay tuned for more information. Thank you.